Congratulations, your development permit's approved. But now this is where jobs get either really expensive or they get really efficient. The main question we're trying to answer here is, what is the purpose of your building? Every beam, every footing, pile, they all have to be dictated by what the purpose of your building is. If you build without specifications for your desired use, then you're either going to pay way too much to an engineer to design them or to not design them because they're so over designed that you're just going to pay out of your pocket. So this is where it's very important to understand what you're going to be doing in that building and what you're going to be doing in the future to make sure you aren't wasting time and money. A building permit isn't just a piece of paper you submit to the county. It's where your design takes an engineered reality. Every footing depth, door opening, wall assembly serve one purpose and is the purpose of that building and what's going to be taking place in there. So you have to be sure that you know exactly what you want to do in that space going forward for years to come. Will your building be designed for storage, light or heavy duty use, some heavy equipment, or will it be just basic woodworking? You need to know these things because a shop built for storage, even though the pocket might look exactly the same as far as dimensions, the structure is very different than one for heavy equipment. So if you don't have that honed in up front, engineers tend to overbuild to compensate just in case. Our next step would be to get an architectural designer in and also an engineer. But this can be one of two things. This can be consolidated where one company does both, or they're separate companies. Both have their ups and downs. When you consolidate those two, it's just for ease of construction. One less person you have to deal with, one less part of coordination. And if you split them up, you might save a little money up front. If you're building residential, it's important you're scouting residential engineering companies and residential designers. This is where optimization saves you money. When the engineering firm is an industrial-based group, they will compensate with larger steel members, bigger beams. Every aspect will be larger and more costly. When their design purpose is residential, they look to optimize because they realize homeowners don't have the same money large companies do, and they don't have the same needs. They need basic functions based off of their design purpose and what they're using that building for. So if you don't do your research and you go with a company that's industrial based, you're going to pay more upfront costs. And it's not because that engineer is a bad engineer. That is how they've been trained. And if you talk to a residential engineer and an industrial engineer, they will tell you there is more than one way to skin a cat. So they will not ridicule each other for their larger beams and larger size requirements because it works. It takes care of everything. You don't even have to think about it. Another thing that comes into play here is context. Does your building fit the context or the visual language of all the other buildings in the area? Is the requirements by the county and the structural architectural designs, are they met? I could have done a pole building. Pole buildings are quite cheap to build, and maybe I could have had a dirt floor for a couple of years. But looking at buildings around in my area, most are built on grade beams or footings. So I had to take that into consideration. I had to take water table into consideration. The back of my house used to be swampy. It's been a drought for about 6 years, but when I built my home, I had to dig holes and put pumps in to make sure that the water didn't come over the foundation while I was building. So that's why I went with a grade beam with steel piles, so I could keep everything elevated and not have to dig into the ground. I figured later it would just cause a lot more headaches if I was to do a foundation and have to dig 5 to 8 feet into the ground. After we have the designers and the engineers involved, one of the most important things we do is review that package. When we look at our drawings, we have to dissect every aspect of those drawings to make sure we understand. I made this mistake multiple times in the process. I had to go back to those designers and tell them that I didn't want this as part of my plan. For example, in my plans, in the details, there was a beam labeled JBS, and that was the vertical structure over my garage doors. And I didn't look into exactly in the appendix what the JBS stood for, but what it meant was joist, beam, steel. So the designer and engineer put a steel beam in my wood building. And when I looked at the cost of that steel beam was astronomical. And when I had looked into other buildings, I had no idea why that was in place there. But I didn't find this out until I was already into the project where I'd accepted those drawings. So I had to go back and get revisions, which cost me time and eventually would cost me money. Because I didn't research the company and I was looking to consolidate that coordination because my companies were integrated. My designer was also my engineer, which made things more efficient for things going forward, but it didn't make it as efficient in the long run and probably cost me 10 to 15,000 from the start of the project to the end of the project. When I realized the company was more commercial based. When others had looked at my drawings, all other trades had questions based off the reliability or the extent of the size of beams and the size of joists and rebar details. Every aspect was affected from the point that I got those drawings to the end of the project, that I had to go back to the engineers and say, this isn't reasonable based off what I want to accomplish in this shop. And the trades, each of them individually, are coming back to me with questions of what are you doing in this building that dictates the size and the structure that you're going for, because they hadn't seen it in regular residential construction. What we're taking away from this is that the building permit process rewards clarity. The clearer you are on your design functions and what you want as an overall product, the clearer the engineers and architectural designers are. And that's where optimization takes full throttle into action. And that's where we save money, we create more efficiencies, and we really dictate the pace and the cost of our building. Remember, with counties and municipalities, there's no right answer or checklist that works with all of them. Next, we can go over the building permit submission process, which was pretty basic as far as just grabbing the application for the building permit, as well as the drawings. The drawings are very integral before you submit it, that you confirm all aspects of it, because you don't want to have to go back to the county and say, I made these revisions, or when the inspector shows up on site, that he says, why are these different from what was submitted to the county? So make sure those are tuned in before we hand in the submission. As well as I had a fire safety plan for the area, and I had to have a copy of the building permit that was submitted to the county on site. So when inspectors get there, they have a visual, and also that fire safety plan to make sure that all trades know where the muster point is. I included the letter of intent just in case they had any other questions. But other than that, it was pretty straightforward. Again, the main thing, if you're stuck at all, is to call the planning and development department directly, and they're the experts. Like I said in my last video, they're there to be your concierge to help you through this process. They don't want to see you fail either. If you like this video, again, please give me the thumbs up and subscribe for future videos.